Today we're talking about AWS messaging and queuing. And the whole idea is just to see how messaging and queuing works in AWS and how it actually connects to all the other services. And this is key if you actually want to build like either serverless applications or applications that scale. And I'm talking about real scale, right? There's no way you're not going to deal with these two services that I really want to mention today. Now we're going to see like an example, right? So we'll see what's synchronous versus asynchronous communication. What does it mean? Like sometimes you see sync versus async. What does it mean? And then we'll see application decoupling. What are the strategies that are out there for doing that? We'll see how Amazon SQS helps us do some of those things and how it also gives us two offerings, standard and both FIFO and then FIFO queue. We'll see SNS, what it does and how we can use it. I would introduce you to fan out, which is like something you probably need to just know right now, and maybe we won't go into details, but it's a good idea to know. And then we'll see Amazon MQ for traditional messaging protocol. If you actually wanted to do something that pretty much you had like something that was working on premise and you wanted to move it over to AWS, so I'm going to show you all that. So let's talk about synchronous versus asynchronous communication, because it's important for you to actually know why you need queues, right? So when you think about synchronous kind of communication, right, you send a request to the server, you would wait for the server to respond, right? So you can see direct API calls between services, right? You're more or less like sending a request and you need response. It's more or less like you send a request and you're waiting, right, to receive the response. So there's really tight coupling, right? Because when you send a request, you're waiting for the other end to respond. And that means there's coupling. It's like you have to wait for the response to get back to you, right? So if you think about it, like your web app is making database queries, that's like an async call that has to wait. The point is that it's like an established connection and you have to wait for the response to come back, right? But when you think about it, asynchronous communication, there is also that option. In some cases, synchronous communication is the way to go, but sometimes async can also work, right? Think about it. You want to generate a report. This is me giving you an example before going into details, right? You want to generate a report, and in the process of you generating a report, you don't really need to wait for the report. You don't have to sit in one place and wait for the report to be generated, right? You can kick off the report, go and generate a report, and then you can go on and do whatever you want to do, right? And at the end of the day, something can notify you and tell you, oh, the report generation is done. This is your report. That's like an async pattern, right? So if you look at it on the other side of the async, you send requests to the server, and you just go and chill, do other things that you want to do. And then at some point, the server, you find a way to be notified that the server is done with its processing, and then you get the response, right? So message sent through intermediary, which is one of the, we'll see some of the intermediaries on this call, right? So no immediate response needed. That's exactly what I explained, right? That's the whole idea of async. I think in JavaScript, in Python, you see async communications as part of even the programming language construct, but it's a pattern, right? So what does it? It obviously removes that tight coupling that we saw with synchronous, right? So it means loose coupling between components, meaning you send a request, you're not bound to wait for that request. You can just go and chill, and then when the request is done, you get the response, right? So I did use like a report generation process, but this is like you placed an order. Do you have to wait for the email to be sent to you immediately? You could go and do other things, and then behind the scene, an email is wired to you, right? So that's how you can. That's one example of like having like asynchronous communication, right? And there are many advantages to it, because, for example, if you want to send an email in a web application, and that's how most of the web applications that you use, that's how it works, right? You fire a command, or like you call an API to say send message, but you don't need to wait for it to go to the server that will send the email or do all those things, right? It can actually tell you, oh, your email is processing, right? It returns the message immediately. It doesn't mean the email has been sent. Behind the scene, something else is doing work to actually send you that email, right? So that's the async communication we're talking about. So when you now think about it, that also brings a kind of pattern, right? That you also need to know. Monoliths, because in the world of whether it's software engineering or cloud engineering, there's always the concept of monolith or microservices, right? So monoliths, obviously, there's a lot you can learn about monolith and microservices, but it's what I share some things about it. So when you think about it, we were talking about synchronous. For monolith, for example, you can have many services, right? So one application will usually have many services. But in the monolith setting, there's this tight integration between the services, right? So it's like there's this very tight coupling. The services, they have this strong dependence on themselves, right? What it means is that somehow we bundle them together, we deploy all of them together. They just have to more or less like stay close to themselves. That's how monolith works. What it means is that single point of failure, right? Because if you are deploying them together, it means that even if just one service should fail, their deployment, you pretty much will roll back everything, right? Because all these services, they're all bundled together, right? It's also difficult to scale individual components. So if you have like a monolith that has so many services in between, but it's not, it means that you would be treating them as a single unit, right? You will be treating them as, and this is important, whether you're a developer or you're a cloud engineer or you're a DevOps engineer. This is important. But again, which is where microservices comes in. What it means is that you can't have independently loosely coupled services, right? So you can have services that are completely independent from themselves. But the question is that once you create that independence, how will they know? How will they pretty much know? How will they be informed something is going on, right? They probably wouldn't have to pull the database to know if something is going wrong, right? There has to be like messaging going on between them, right? So what it means is that, and this is why this topic that we're talking about today shines, because microservices is the thing. Nobody monolith is still there for a lot of people who are still transitioning. But if you're starting your project today, I think most people will build microservices, right? Because why? Messaging is now easy to do. The whole idea is that you can have services operate independently, but still can communicate. Meaning, oh, I'm the report generation service. You need a report, just let me know. Send me a message that you need a report. And once I get that message, I'll go and generate the report, right? So it means you can keep services loosely coupled, but yet still get the value you want, right? So fourth, isolation and resilience, meaning each service will have their own life cycle, their own deployment pipelines if possible. There's so many things that you can do around that, right? You can also have individual teams for different services, for example, because it just depends on how far you want to go with the loosely having like a loosely coupled system. Individual systems can scale on their own, so it's something that is good. Better development team autonomy, and that's exactly what I was saying. So each team, so you could have, it depends. Report can be small, but in some companies, a report is a project on its own, right? Because it depends on the kind of report you are generating. So you can have a dedicated team that is doing the report service. But what it means is that it's doing this report service, but still, it still can know when a report is needed and it goes to work, right? With the help of a sync communication, right? Cool. So that's some very, very good introduction. This is a pattern that is not new to the cloud. It's there. It's always been there outside of the cloud. Like I always say, the cloud is not trying to solve what does not exist. Many of these things people have been doing like asynchronous communication. But again, when you now move your workloads to the cloud, how do you do all that? Is what we'll be discussing today. Which brings us to the first service we'll be talking about, which is Amazon SQS, right? So it's a fully managed messaging queue service. The whole idea is that if you think about when I talked about async versus synchronous, and I talked about monolith versus serverless, right? It means there is some messaging needed between those services once you decouple them, right? The question is that there has to be like a place, maybe like a queue. That message is probably sitting. So service A sends something to the queue, and then service B will process it when it has a capacity, right? So it means that sometimes you pretty much don't need those things like to happen immediately, and in some cases you also want them to happen immediately. But the most important thing, there's a queue. You can have workers go into that queue and then consume it, right? So so it actually enables the decoupling of application components that I mentioned just some slides before now, right? And it's pay-per-use pricing. So we still have that serverless offering, right? You're not provisioning server. The most important thing, if you don't have messages in the queue, maybe you won't be incurring any cost, right? So it's also pay-per-use pricing, which is why it is largely adopted in the cloud, because who doesn't like it? No infrastructure to manage, like I mentioned. Actually, so when you think about the key benefits, nearly unlimited throughput and messages. So what it means is that scale is guaranteed, right? It's in the cloud. Message retention, meaning you can keep your messages in the queue if you don't consume them 14 days, right? Which is good. So it means there is like some storage layer attached to your queues, right? So it means nobody's forcing you to send the message and consume it immediately. You can't keep it there and consume it after some time, right? Server-side encryption, as with most AWS services, there is some sort of encryption you can have on your queues, right? Dead letter queue support. So what's dead letter? Think about it. A queue, there's a message in the queue. An application is trying to process that message from the queue. It fails processing it. It tries the first time, tries the second time, and tries the third time. At some point, it can actually send it back to that message can be put in the dead letter queue. A dead letter queue is just a queue that says this event could not be processed, right? And then you can actually go and read those messages at some point to see why are they failing. Is it that the messages are different in terms of like their structure, or maybe there's a particular customer ID, you might have to troubleshoot it and see why is this particular customer ID failing, right? But the whole idea is that you can have a queue that is working. You can also have a dead letter queue for events that are failing, right? Cool. So when you think about queue types, there are two types of queues majorly in SQS. There's standard queues, right? Very high throughput. That's one thing that is known for. So it has very high throughput. The only nuance is there is that it has like at least once delivery guaranteed. So what it means is that at least once your message is going to be delivered. So you can't lose any message. That's just what it means, right? But at least once, you get at least once. But again, that at least once means you can get it more than once. So some duplicates can happen if you're using a standard queue, right? So ordering is not guaranteed. So what it means is that it's best efforts ordering, right? So there is no strict order at which your messages are delivered. Like I mentioned, duplicate messages are possible, right? Because if you have at least once delivery, what it means is that you can have more than one time messages delivering more than once, right? Which is where the duplicate can come in. But it has its own use case. So it has more throughput. When you think about throughput for applications, standard queues will give you more throughput. Although there are ways you can make FIFO queues to do that same thing, but out of the box, standard queue is going to give you that possibility, right? So other processing systems, pretty much, if you have like another processing system that doesn't really need to follow a queue, like a first in, first out pattern, you can use it. Whether it's image, video processing workflows, for example, like I said, if I have an application and I need to process an image or a video, for example, I don't have to wait in my UI for that video to be completely processed, right? What it means is that I can send a message to the queue saying, please process this video for me. And then something behind the scene that is a service that is known for processing videos can listen to that queue, get the event out, and then process it, right? Using its own capacity and his own, whatever was designed for that service. And then when it's done, you can also inform the other service that, oh, I'm done with processing this queue. And then, it brings about that async nature that we've talked about, loosely coupled applications, but doing the work and doing it effectively, because now you can have a service that simply does video processing and that's it, right? So also batch processing, you can queue jobs in your batch. I think we discussed batch. We just didn't go very deep, right? But batch is a thing in AWS. What it means, you can keep a queue. You can keep a queue and then have like a batch job processing them, right? So it's just like, oh, are there items in the queue? Run this job, and then it keeps processing that. And these are the things that gives you resilience. These are things that makes you it makes it easy for you to split your application in AWS, and have it just work how you want it. So what else? So we've talked about standard queue. There is also the FIFO queue, and we're going to see some of these things in the UI. But it's FIFO is just first in, first out, right? I know there are different types of other queues like last in, first out, or first in, last out, right? But this is really FIFO, meaning first in, first out, right? The other one we saw it was at least once processing. This one is exactly once processing, right? So once your message is processed just once, right? Strict message ordering. That's why it's FIFO. There's like an order it has to preserve. Yeah, in terms of throughput, you have to optimize FIFO to give you high throughput, but standard, it comes by default, right? So up to 300 transactions per second, but you can actually optimize FIFO to get even more throughput, okay? No duplicate messages, but one thing you need to understand is that for it to be FIFO queue, it has to end with .FIFO, and that's just the difference, right? Standard queue, you can name it whatever you want to name, but for FIFO queues, they are named .FIFO. Use case financial transactions, for example, you know how it is. Most of the times, financial transactions are ordered, right? You need to debit, you need to, it has to go in a sequence. So if you want to do those kind of systems, you obviously need to use like a FIFO queue, right? Or order management system where it has to go through like a different, like a step-by-step approach to solving the problem. And then chat, you know how it is. Chats are ordered. If you check all your messaging platforms, you notice that the messages, they actually arrive in a given order. Like it's how it's sent. It has to follow that order, right, to be delivered to you. Cool. So key concept you need to know about SQS is SQS is that message body. I think SQS now has more support for a larger message body. But the thing is that there's like a message body, which means which message are you sending to the queue, and it has like a size that it supports, right? Message attributes, it means that a particular message you can put attributes, right, just to differentiate a particular message from another message. Yeah, you can also do receipt handling, just when message is deleted, so that the queue is like what you do after you've received the message, right? Do you want to delete it from the queue or you want to leave it in the queue? It's all up to you. So visibility timeout is also something you need to know, because when you, for example, there's a message in the queue and you take it out, right? What it means is that the message has to be hidden, right, until the timeout for being visible is exceeded. The idea is that if you have multiple workers pulling a particular item from the queue, you don't want other workers to try to process that same thing again. That's why it's hidden. It has to be hidden, right? So what it means is that you have to process it, and then it's only when there is an issue it becomes visible again for another worker to pick on, right? So the whole idea is that it's just for you to prevent duplicate processing, not in a situation where one worker has picked it up and then another worker is also trying to do the same work, right? Message retention, yeah, obviously there's a default, but you can have messages, like I mentioned, in the queue stay up to 14 days, right? Cool. Long polling is something that is also there. What it means is that you can actually do there's short polling and then you can do long polling. The whole idea is that, remember, it's a queue and something is trying to process it from the queue, right? So imagine I'm a worker, I'm trying to go into the queue and there's no message I'll just return immediately, right? That's short polling. The whole idea is that even if no messages, just return immediately, right? What it means is that you can actually return empty responses also, right? And then because SQS charges you for some of the API calls you make, you will get more cost from like your API calls that you make to SQS, right? But that's where there's also long polling. Long polling is just that you can wait longer to make sure that there is message, right? So that you're not just frequenting and then not getting any message. You can wait up to 20 seconds for message. And the whole idea is just for you to reduce empty responses that you're going to get. And then you're also going to lower your costs, right? Especially around API calls, and obviously there's just how it is enabled if you actually want to use it. So we've talked about polling and we've talked about visibility timeout. And then dead letter queue is worth mentioning. I think I did talk about it at the beginning. Capture messages that fail processing. It's a separate queue basically that keeps track of the messages that are failed. prevent message loss. The whole idea is that it's there. Remember, it will also stay there for another 14 days if you support it, and then you can go back there and check what's wrong. Why is it not working, right? So, like I said, also failed messages will just move to the dead letter queue automatically. You can analyze failures and implement fix if there is any issues with that particular message that you're trying to process and understand why it's failing, because it's going to be stored in the dead letter queue for you to. And then you can actually redrive. That's some advanced concept, but you can redrive the messages back to, maybe you fix your logic, and then you can redrive your messages back from your dead letter queues back to the main queue. Okay, but all that is advanced stuff. I'm just introducing the concept to you. Okay, so that brings us to before we talk about SNS. I'm here in queue, and here we're not just going to create queue at the end of this class. We're actually going to see all the things that we mentioned today, put it into one pattern, right? That is related to some of the patterns we've used in the past, but we'll be introducing them one after the other, and then see how we can bring all of them together, right? So the thing is that we're just going to create a queue, and I'm going to create queue, and I'm not going to destroy it because we're going to use it later, right? To bring the entire pattern together. But we will start by introducing each component, and then we will combine all of them together after the class and see, or at some point, right? But the whole idea is that you can do queue. You can create a very simple queue. Like I said, there are two kinds of queue. Here, we're just going to use standard queue. We're not going to do FIFO queue, right? We'll just use standard. But again, the difference is that standard, high throughput by default. FIFO, less throughput, but you can make it get more throughput. It's just that there's some customization that you need to do, right? But standard, obviously, but you need to understand one is really ordered, the other doesn't follow like a strict ordering. Okay, so I'm just going to call it my queue. It's as simple as that. So these are some of the things that I mentioned. Visibility timeout, you can see, should be between 0 and 12 hours, right? So what it means is that if I do 13 hours, obviously at some point it's not validating it, but maybe if I try to create it, it's not going to allow me because it's saying it needs to be between 0 and 12 hours. And if you see the info here, it's really saying visibility timeouts says the limit of time that the message received from the queue by one consumer will not be visible to other message consumers, right? These things throw people off when they kind of are getting used to queues. But the whole idea is that when you consume the message as one consumer, how long should it be hidden from other consumers? That's really what it is. It means within that time frame, it's not going to be shown to someone else until after that time frame. If you don't do anything, that's when it gets shown to someone else, right? So we will keep I'm not sure what the default was, but again, I mean, we will just keep it at 30 seconds, right? And so delivery delay, obviously there's some things. Message retention, you can see you can keep your messages in the queue for up to 14 days, so it's fine. I think I said in the slide, but it looks like there's now like a there's now increase, right? So it means you can have 1 KB up till 1 MB. That's what it means. So your message size can be up to 1 MB. Okay. And then receive wait time. I think I'm just gonna leave many of these things, right? So server side encryption is here. It can be enabled. Amazon SQS key is what we're going to use. So SQS is also one of those services that use like a resource policy. We've seen that with S3 before, but SQS falls into that. What it means is that your queue, you can actually decide who can push, who can pull, whatever, who can do anything with the queue. So in this case, it's very simple policy. We're not going to worry ourselves. It's just saying that anyone that is inside of this account can deal with the queue. So it's fine. We'll take that. What else? Which source redrive policy disabled dead letter queue? We mentioned it. It's disabled. I'm not going to do anything. I'm just going to name it. I'm going to give it a name and say my queue, right? Good. So, and then I'll create a queue. So it's that simple, right? We now have a queue. So what it means is that we could go to the queue, click on this one and say send and receive message, right? So I can type hello world. Remember, this is for me testing. I'm testing from the UI, but in the real world, ideally is an application. And we'll see an example. An application will send something into, but you can test the queue, right? And play with it. So what it means is that I can say hello world, right? In this case, it's the message body. Delivery delay, there's no delay. Here you can actually test in the UI to see how it behaves, right? Whenever I put like a message attribute or you put like a delivery delay, what's going to happen, right? So I'm going to send the message. So the message has been sent. And so what it means is I can go back to the queue, right? So I'll go back to queues. Let's see. Okay, yeah, so go back here, go back to send message. I'm just going to type hello world again. And then send message. Did you say send again? Your message has been sent and it's ready to be received. So if I pull for message, you can see I have like 2 messages, right, that are in the queue. If I check the content of the first message, it's here. This is the second one, right? This is the second one that was sent, and this is the first one, right? Hello world. So here it's still pulling for message, meaning it's still just checking the queue and trying to pull for more messages, right? So let's give it time to do that. You can see messages. If I go back to this queue, I think I was too fast then, but you can see it has 2 messages in the flight right now. So there are 2 messages actually available in the queue, right? And here we're done polling for message. What it means is that if I refresh this page, what's going to happen? Uh, so what you can see is that the message has gone, right? So the message is no longer here, but it still tells me that there is like 2 messages here, right? So the thing is that even if I pull for that particular message, for the visibility timer that we have, it's not going to be shown to someone else, right? But once that time has passed, it's going to another consumer would be able to get that same message, right? So we can obviously pull for the message. We have these 2 messages here. I can pretty much just fake what it looks like, right? After consuming the message, you've done something with it. Maybe view the details. There's no attributes and there's nothing, but this is basically some of the details. And then I can basically delete the message, right? So when I delete the message and I go back here and I refresh, you see there is like 1 message in flight. And the reason why you have 1 message in flight is that because we've polled for 2 messages, right? So we've polled for 2 messages, meaning 1 message right now cannot be used. You can't really use that message right now because it's another consumer is using it. But in there, we've already deleted 1, and that's why you see message count here has become 0. But actually, no, it's 1, right? But because this guy has to tell us if he has finished processing it, if not, after a while, it's going to return back to the queue. You can see while we're on the screen, it's back, right? It's back to 1, and then there's none in 0, which means that it has passed the visibility timeout and it's back to the queue. Another consumer can process it. Cool. So we're going to stop here. We're going to come back and use the same queue for something else, right? The entire flow we want to build today, but we'll pause here and continue the slide, okay? But again, we've shown some of the basic configuration that you need to have in a queue and exactly how it behaves, right? But we're going to revisit it. So let's keep this queue handy. So that brings us to, we've just talked about queues, right? Queues are really what they are, especially when you want to queue an event. In this case, do you want to have strict ordering using a FIFO queue, or you want to use more or less like you don't care about the ordering in which it comes in, right? But again, pop sub is something, remember, the task at the beginning was still talking about monolith versus serverless, and we're also talking about synchronous versus asynchronous communication. And we're talking about the things that would allow us to do that, right? So SNS is also one of those services, right? I've shown SNS severally on this call, but again, here we're going to be doing more with it. And the point is that you can have pub sub messaging, right? So somebody's publishing and somebody subscribed to it. And that's really what SNS is. It's really a pub sub messaging service in AWS, right? So you can publish messages to a topic that you have, and then you can have multiple subscribers. So multiple people can be listening to a particular topic and again get notified if you publish to that topic, right? And there are many reasons you might want to do that. Maybe you want to be like, there are people listening. It's just like me. I think I've mentioned it here that I do have subscribers on this platform, and I usually tell people turn on your notification bell. So you can imagine once you turn on your notification bell, that's like a subscription you're creating. And what it means is that you're interested in knowing when I come live, right? And so when I'm live, it pushes message to my subscribers. And that is exactly how SNS works as a pub and sub model, right? So people are subscribed, and then they get notification whenever there's a message in that topic, right? So push-based delivery model, which means you have to push to it, and then whoever is subscribed gets the message. And we're going to see practical example, right? Key features, you can do fan out messaging patterns. What it means is that one SNS is getting it, is fanning it out to other places, and there are many applications. There are many more or less like advanced use case where that becomes very important, right? Multiple protocol support. What it means is that you can subscribe an email, you can subscribe and a Lambda function and all that, right? You can also do message filtering, although we'll not do that. That's a bit, we'll not go that far, but you can filter. What it means is that when you're subscribing, you can say, I'm not interested in every messages, all the messages that are coming to this topic. Rather, I'm interested in messages that have this attribute, right? So it's a very powerful feature. Just take note of that. The fact that you're not just subscribing to, it's like you're subscribing, but I'm only interested when I'm live. Maybe you're not interested when I make a post, or maybe you're not interested in when I put something on my story. You're only interested in when I go live. So it's like you're creating a filter for yourself to say, I'm only interested in when it goes live and not when it makes a post, right? It depends on you. You can also do mobile push notifications, right? So when you see it's simple, you're a publisher, you send to an SNS topic in behind the scene. That topic just needs a set of subscribers, and in as much as they are subscribed, they are going to get the message, right? So topics are really communication channel. Publishers send messages to the topics, and then you can have up to 12.5 million subscriptions per topic. So you can imagine just in one topic, you can have like 12.5 million subscriptions. So even if you were to subscribe like 12.5 million emails, you know what that means? That means your topic can actually be able to send messages to 12.5 emails. I mean, that's like scale from just the beginning, right? So there's so many subscription protocols. You can have HTTP, email, SMS, SQS, Lambda, and even mobile push notifications. Okay. So you would use one of the protocols on this call, right, to show a demo. But there are many more you can do. So when you now think about what's the difference between the two, when you think about SNS and SQS, SNS versus SQS, one is push-based, right? So it means you're pushing, basically. But one is pull-based. Something is in the queue. You have to pull that item out and process it. That's the way it is. Remember, it's a queue. It's going to be there for like 14 days. But within that 14 days, you have the, there's time for you to pull it out and then what do you call it? Process it, right? But the other one, you're just pushing, basically. And there's a reason also why you need, like, when you think about them, they do different things, because SNS is not going to, persist whatever you send to it, right? It's not going to persist it. It's like, it doesn't have a data, it doesn't have a store back in it. So it's basically, once you send it, it's hoping that you have like something subscribed to it and it sends it to the subscribers. That's it. Unlike SQS, where it's like it has its own storage, yeah, you can collect the thing and store it. And that's why SQS and SNS, they go hand in hand, because SNS can be that push based guy, and then SQS is a place where you can keep the events for a while and process it when you have enough capacity, right? So that's why both of them go hand in hand. And in a lot of production grade systems, you will see these two patterns, at work. So multiple subscribers is what you get for SNS. Single consumer, obviously, per message, right? Because once a consumer fetches a message, it goes out of the queue until it is processed, right? Or until it is brought back to the queue if it exceeds the visibility timeout. Real-time notification is one thing you get with SNS. Message persistence is also what you get with SQS, because the messages can be there for like up to 14 days, right? Like I mentioned, no message persistence on SNS side, right? And that's why there's like both of them, they complement each other. Use case broadcasting, if you want to do broadcasting, right? All the subscribers are going to get a notification. But if you look at SQS, queue, work queues, or batch processing. So they have their strength, area of strength, and where you should use one and the other. I'll just mention fan out pattern here because it's something you don't need to know. Like, you don't need to take it if you want to, you can. But because you can have multiple subscribers to an SNS topic, right? So the whole idea here is that you can actually have multiple queues subscribe to one SNS topic, right? So it's like you're keeping the same copies in different queues, right? And there are many ways you might want to do it. Maybe you want to have different part of your service only listen to a particular queue, right? And then have the message duplicated to those queues, and then everybody's like, you're fanning it out to multiple queues, and then maybe the different services are only listening to a given queue and they're processing it. So A is going to get a copy, B is going to get a copy, C is going to get a copy. So SNS actually supports that. It's something you should know at some point. So SNS received the message, multiple queues subscribe. Remember, SQS is a protocol, and you can have multiple queues subscribe to like one SNS topic, right? And then each queue process independently, depending on what you have set up. Combines the benefit of both services. So SNS, because you can have multiple subscribers, and then the queues can keep that persistence for you, and then you can have like your workers doing the work, right? Parallel processing, independent scaling. And remember, the queue in this case can actually filter, they can actually be subscribed to the queue based on an attribute. So it means QA might not receive exact copy. It could be QA is only interested in events that are I want to print. QB could only be interested in events that says I want to, yeah, because of those attributes that a topic can have, right? So guaranteed delivery, obviously, because SQS is going to persist the data. Yeah, e-commerce order processing is a use case for that, right? Because for example, like I mentioned, you could have attributes and say QA, this is orders started, QA is going to process that, maybe orders finished, QC is going to do that. It just depends on your design, but these things are there for you to be able to do. So before we go to Amazon MQ, let's put all this to work, right? So we have a queue here. We have a queue right now. It sends out one message, right? So what I'm going to do is that I'm just going to. There is also another option that I didn't show you. So let me try and bring this down a bit. Let me bring my face down a bit. There is also something I didn't show you. We only did purge. We only did send and receive message, but I can actually purge. So in this case, because what I want to show you doesn't need that message that is there. So I'm just going to purge the queue. So there's also an option for you to purge. It's showing me there's one message there. It's just going to get rid of the message. You don't want to do this in a production system, right? But right now we can purge it. Cool. So we have this. Let's go back to SNS. We just talked about SNS. So I'm going to do SNS here. And then I'll go to another tab and create a topic, right? So I have no topic here. I'm going to create one. I'll call it my topic. So like you see, even SNS can have a first in, first out topic, which can only be used by first in, first out queue, right? But here I'm going to use like a standard topic, right? There's nothing I'm ordering. So I'm just going to call it my topic. I think you've seen me create topics so many times on this call. Although this is the first time we're going to use it like in the serverless. I'm going to use it in the serverless pattern so that you see it. But this is my topic. I'll say my simple topic, right? Good. Encryption is optional. Access policy is optional. Delivery, all these things, that nice stuff you can have, but they're not. It's not what I want to show here. But again, usually I encourage just start stuff. Just make sure you're in the habit of tagging. Tagging is good, whether it's you learning or even production, right? So I'm going to create topic. So right now there is really no subscription, right? So there is nothing subscribed to my topic, right? But I remember I told you that you can have subscribers, right? So let's say we want to create subscription. This way I talked about the protocol. You can see the different protocols that you can have. So you can have SMS, you can have HTTPS, platform application endpoint, HTTP, email, all these options are there, meaning you can have subscribers of this form subscribe to a topic, right? What it means is that they will get notification or they will get something when that message gets to them. So what I'm going to do here is you can't create subscription from here, right? You actually can. Remember, on the queue side, we've already been able to more or less like send messages to the queue directly. We interacted with the queue directly. But what if we wanted to interact with the queue through an SNS? So what I'm going to do is there are multiple ways you can do. You can do it from the other side, or I can do it from here. But here, I'll choose to more or less like create a what do you call it? Queues. This is my queue. Subscriptions. Uh, this subscription. Did I create this? Did I create this subscription? Mm, I can't remember creating. Have I created it? I've not created any subscription. Okay, let me see. I don't know why this one is here. Um, I've not created this. I only created a queue that has one message. I thought I purged this message. What am I saying? Okay, let's start. So what I'm going to do is that here in this case, this queue, I want to subscribe it to an, if you remember on the SNS side, we're looking at it, we saw protocols, right? You can also see at the point of creating a subscription, you can have a filtering. The whole idea is that maybe I'm not interested in all the messages that come into the SNS topic. Maybe I'm only interested in a subset, and there I can have like an attribute that filter. But what I'm going to do is that I'm going to go here and then I'm going to subscribe to an SNS topic. In this case, I'm going to search. I think it's my topic, right? So I'm going to say, so what it means is that I now have a subscription, right? So I've refreshed, there is a subscription to this topic. So if I go to this topic and I check subscriptions, I seem to have a lot of subscriptions here. I have so many subscriptions, but let me see, which topic did I create? Is it because I've used the same name before? What? I don't know. But you can see there is this subscription, right? And it's for SQS, right? So my queue. So what do you think is going to happen if we publish a message to this? So let's try. So let's just do. I know we've done SNS before, so we'll just do hello world. Maybe we'll just do hello world, right? So we'll do hello world. Um, this is like the subject. I'm just going to do hi. I'm just going to do hi. It's Brainyl, right? So I'm just going to do this, and then in this case, I don't have message attribute, right? But in the real world, sometimes you need that message attribute because why? You can have subscribers that are only subscribing based on a given attribute, right? So that's where you can set the attribute. In this case, I don't really care, so I'm going to do publish message. So the message has gone there. I have one subscription as a queue, and the question is that what is happening in the queue? So I'm going to go back to my queues. I'm going to refresh. So there's one message, and as usual, you can basically go inside that queue now, and you can receive the message, right? So you can do things like in this case, I think we did polling for message. So we'll poll for the message. The message is here. If we check the message, the content is really this. These things are important. You know why? This message here is important because if, for example, one of your service or one of your worker needs to claim this message, it needs to understand the format, how the message is, right? So that if maybe your workload, whether it's in EKS or it is in EC2, whatever it is, it has to know the pattern of this message, right? You can see how this message is. So if you have like a Lambda function that needs to poll for this message, it needs to know the exact format in which the message is going to come so that you can test that service in isolation. And then when you create the connection, you know that everything is going to work as is, right? So there is one message from SNS that was just a test message, but that's not what I want to show on this call. So what I'm also going to do, I'm going to go back to my queue. There's one message. I'm going to purge it, right? Because but at least now we know that from SNS, there is like messages going to the queue. So we've created an integration in this case. So I'm going to purge. I think that's what it wants me to do. Okay, so I'll purge it. So what I'm going to do is I'm going to go to EC2 and create an instance, right? So I'm going to create an instance. We've done this before in a different way, right? Using automation documents, but we're going to do it in a different way. And this is a new pattern I want to show. So I'm going to come here and I'm going to do, I'm just going to call it my web server. I think it's this server, right? So I'm going to call it my web server. It's going to be Amazon Linux 2. T3 micro is fine. I'm going to proceed without a keep here because I'm not showing anything SSH here. I don't need SSH to be enabled. I'm going to turn that off. The only thing I'm going to do is I'm going to use, I don't even need systems manager to be there because I'm not SSHing into this machine. So I don't mind. I'll just leave it like that. So it's here. Let me just be sure what I want. I think that's it basically. So I'm going to launch the instance. So we go to instances. We go to instances and we'll see instances that are launching. So there is this instance that is currently trying to launch, right? So what I'm going to do is that I'm going to go to alarms, right? It says there's no alarm associated with this machine for now. So I think we've seen before where we did like an alarm that sends something to an SNS topic. So we're going to expand on that. So in this case, I'm going to create an alarm for this particular EC2 machine, right? So what I'm going to do is that I'm going to create a topic. So in this case, I'll use my topic, which is the SNS topic in this case that we want to notify if there's an alarm. Here I'm just going to use a threshold that says 80%, right? So if it exceeds 80%, but it doesn't matter, we'll have to test this manually. So what it means is that we can just create this alarm, right? So here we don't have any action. I think the last time we did like using an action, but in this case, we're just using a notification. So we are just going to do create, right? So we have this alarm created, and we have the EC2 machine running, although it's still in initializing phase, right? Cool. So let's go to alarms and see what we have. So that will be a CloudWatch feature, right? So we'll search for CloudWatch and see what we have there. So I'm going to go to CloudWatch, and then I'll go to alarms. So I'll go to alarms, all alarms. We have one here, right? Here. So right now it's saying insufficient data because yes, it's understandable. You know how it is, right? When you starts from insufficient data, it moves to okay, and then it can also move to an alarm state, right? But in this case, I think we did configure it to say, if it's in an alarm state, pretty much trigger a notification to an SNS topic, and also that SNS topic already has integration with SQS, right? Because the good thing about SQS is that, like I mentioned, is the persistence part. Don't forget. SNS is not going to keep the message if nothing is subscribed to it, right? But persistence is what SQS brings to the mix, because now SNS gets it, moves it to SQS. SQS will keep it there for as long as you want to retain it, which we know it supports up to like, what do you call it, up to 14 days, right? So it means that if there is an alarm, I'm using alarm, but there are many, whatever I'm showing you here works regardless of how you want to treat it, whether it's your application that is pushing stuff to SNS, that is writing to a queue, or, but here I'm just showing a very simple case that can be replicated easily, right? So let's go back to the alarms. It's still, it's gone to OK state. So what I want to do is, and watch how I'm testing the systems in isolation. So I created a queue. I was able to send message to it, read the message. That was done. I created an SNS topic. I integrated both of them, right? Because I know a queue can subscribe to an SNS topic. And I was able to even publish message to the SNS topic. And I was able to confirm that the message is in the queue, right? So now I've added a third component, right? An EC2 machine, I've created an alarm. And now that alarm has been tied to the SNS topic. And now I want to trigger this alarm and then see what is going to happen. So at this point, I want to be sure that once I trigger like a message to I trigger the alarm should notify SNS and the message should end up in the queue, right? Cool. So what that means, what that means is that I would go to Cloud Shell. So I'll go to Cloud Shell. I think we've done this before. So we've done some of this part before, but it's good that we're seeing how we can change it a bit to support a different kind of workflow, right? So here we basically just need a simple command. Let me bring that command. So we're going to be doing set alarm states is what we want to do here. So we want to do set alarm state. So I'm just going to paste this command here, and then I'm going to go and look for that alarm. So what's the name of the alarm? The name is this one. Let me see. This is here. So I'm going to paste the name here, right? Oh no, I think I did that wrongly. I think it probably would work. Let me try it. Let me see. I'm just going to do this. Copy. And then paste it. Delete. Okay, I think this, and then I'm just going to set the alarm state, right? You can set states of the alarm. Is what I'm going to do. I'm just going to paste this here and then try this, right? Set states. Yeah, so it's not. So I'm just going to copy the correct command. So this is the alarm that I want to do. I'm going to just copy the complete command. Okay. So it's AWS CloudWatch set alarm state. So I'm just going to paste this here, set alarm state for an alarm, give it the alarm name, and we're setting the state to alarm, right? And the reason is we're testing. Remember, in the real world, we're not doing this manually. It's the application that's going to trigger this, okay? But here, let's just try it. So it's gone. So it means that if you check, for example, you go here in alarm, and let's refresh. There is one that is in alarm. So at this point, I should just go to SQS. I believe that the message should be in SQS. So I'll just ignore even the SQS queue. So I can see there is already a message. Or let me give it some time. But yeah, there is a message. It was showing 0 before, but the message is here. If I go to the message and I do send receive message and I pull for the message, there is one message. If you view it, if I scroll in a bit, this is the alarm message, right? That we've gotten. We've gotten this. So think about it. There's an alarm. The alarm is wired to an SNS. SNS is wired to SQS. And we have this alarm. The good thing about it is that this message, you need this message for you to be able to write a Lambda function or like a service that will help you process it, because this gives you like a schema for you to understand the service you are dealing with in this case, right? So I know in this case, this is the type, message, ID, blah, 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 and all that. So these messages are in the queue. So we have those 3 elements already put together. So what I need to now do is go to Lambda, right? So I'm going to go to Lambda. I'm going to go and create a Lambda function, right? So I'll create a Lambda function. In this case, I'll call it, I'm just going to call it my Lambda function. And then I'll give it a, what do you call it? I'll give it a runtime. There's so many runtime you can use it, but I'll use Python 3.11. Execution role, I'll let it create one for me, but I'll still make some modification to the Lambda function role, right? But create a new role with basic Lambda permissions. The basic permission will basically give it permission to write to the CloudWatch logs. We've seen all that, right? Because when Lambda does its thing, sometimes we you need to go to ideally go to CloudWatch to see the logs and all. So this basic role gives it permission to do that. So we have that function created. So my Lambda function, right, is doing this. I'm just going to create a function. So it's going to use this role. So let's give it time to create. Like Lambda is serverless. So everything we're dealing with right now is serverless. They are all not running. We don't have any machine set up. SNS is serverless, SQS is serverless, and you would only incur money when they have to do anything. And sometimes you need to process a lot of events, right, for anything to happen. So what we have here basically it's a Lambda function. I think I've shown what Lambda function before now. We know that it's basically serverless. You can run your code, right? In this case, we are choosing to run Python code. So I have a code that I've written here, and I'll try to just explain the elements to some extent of the code, right? Because this is part of what's so there's people used to ask, if you're a DevOps engineer, do you need to understand programming? Yes, like I said, to some extent, right? Not like core writing code programming language, like writing application related programming language, but you need to deal with your infra at some point, right? So which is where some of the programming is required, because here we're dealing with infra. So if you think about it, this will be the handler. What the handler is going to do is that it's going to take a message body, right? So it's going to take more or less it's going to take it's going to check. So that's exactly why I said you need to understand what SQS is going to be sending in. But this Lambda function has been written in such a way that it tries to understand. It knows it knows, because I'm going to use this Lambda function to be like a target for SQS, right? So what it means is that SQS needs to understand the kind of message it's going to be getting, right? So this Lambda function has been written that way. It knows that it's going to get an alarm, a message that has to do with an alarm, and then it's going to take an action. So what it's doing is at this handler, we're just fetching a message, we're going through it, and we're doing one thing here. We're just stopping the instance, right? Remember, we've done this with Systems Manager before, like just setting an alarm action. But this is us faking that same thing and using the Lambda function to do it, and just putting a queue in the mix. And the point is that this is an example, but you can follow this pattern to replicate so many examples that are out there, right? So you are basically doing many of this. Like this is just going through whatever a message is coming from SQS and just trying to get the information we need. The most important thing is that we need an instance ID, and that instance ID we want to stop it, right? That's really what this Lambda function is all about. So what I'm going to do is I'm going to deploy it. And then once I deploy it, let me see if I can find like an event, like a sample event that I can use to try it out. Just so, and there's a reason why I'm encouraging this, just so that you know that you can test every part of your system in isolation before you even run the test on it, right? So what it means is that I'm trying to see if I can find a sample event that I can use that I have. Let me see if I have. Yeah, for me to generate like an event now, I have like a sample event, but it's going to be long. But again, I know the Lambda function is already optimized for what I want it to do. So I'm just going to leave it like this, okay? It's already optimized to handle this message that we were seeing here, this particular one. But let me even see if it's easy for me to actually just pipe this into something else. Let me see. Records, message ID, blah, 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 attributes, and then the body. Yeah, it's going to be tricky because I need to pipe this. I'm just going to leave it like this. But the point is that Lambda function currently has been written to process this message. So if you go and check the logic in there, you will notice that it already has like, the logic to process this alarm. That's just the whole idea. So that Lambda is already there. There is already one message here. The next thing I want to do is now make this something that is triggered from the SQS, right? So, one is, what do you call it? One is push based, right? We saw SNS was a push based. But here you have to pretty much pull from, get information from SQS and process it, right? So what we can do is that we can go back to our SQS now. So we'll go to our queues, we'll check, we already have like a subscription, meaning it's subscribed to an SNS topic. An SNS topic we get, and now we have like one message. There is one message, right? But nobody's going to process it there. So it's just going to be here until the message exceeds its how long you want to keep it. So what I'm going to do is I'm going to create a Lambda trigger. Remember, I'm doing it here, but you can also more or less like you can also do it here. There is also like room for you to have like triggers, right? You can see there's trigger, okay? But I'll do it from the queue side. So what I'm going to do is I'm going to configure a Lambda function trigger, and then I'm just going to choose my Lambda function, the one we just created, right? So I'm going to save it. Have permissions, execution role does not have permission to call receive message on SQS. Okay, cool. I think I know what this error is. So the thing is that what is happening is that we're trying to use this Lambda function to be a trigger for SQS, but in this case, it's saying that it doesn't have a particular, it needs this permission, right? Because it needs to receive message from the queue. So we just need to go and fix that. So what we'll do is that we'll go to configuration for the Lambda function, we'll look at the permissions, and then we'll go to like the Lambda role, right? Which is the role that the Lambda function is using. So what we're going to do is that we're going to look at the policy. So there's really a policy that is here, and we know it's the basic policy to create log group, create log stream, and put log events, right? But I want to extend it. So I want to add more permissions to it. So I'm going to do attach inline policy, right? Inline policies will stay. alongside with the, what do you call it, with the entity you're adding it, right? It's not like a managed policy where it stays, it has a lifetime that is outside of the entity. I think we've seen all that. So we're just going to do, I think, sorry, I was here, I was trying to do create an inline policy, right? Yeah, that's what I wanted to see. I think I was choosing the wrong option. So I have a policy handy here that I'm going to do. So I just need to get the instance ID of the EC2 machine. So I need this. So I'm just going to copy it, and then I'm going to put it here. Just then I'm going to give you the entire policy. So I'm just going to copy this complete policy that I have here, and then I'm going to go to create policy. So it's here, we're in this UI. I'm just going to replace everything they have with this one, right? So the whole idea is that, first of all, this Lambda function should be able to stop EC2 instance. Remember, everything has to go with the least privilege, right? So it has to be able to stop EC2 instance. It has to be able to describe EC2 instances, describe the status, and then most importantly, this was what was stopping us. So it has to be able to receive message and delete message, and then even get queue attribute, right? Whatever attribute it needs to do. In this case, I think this is written as my queue. I need to fix it to be, what is the queue? I think it's my queue. Yeah, it's correct. Yeah, so the name is still my queue, but I just need to be sure. Yeah, I just want to make sure that we'll create it once and for all. Okay, it's correct. So I'm just going to do this. Everything looks good. I'm going to do next. I'm just going to call it EC2 SQS permission, right? Because that's really what it is. So I'm just going to create this and create the policy. So the policy is attached to the Lambda function. Now let's try to configure it again and see, right? It says it doesn't have. It does have now, right? So I think when we tried it again, we were now able to add that Lambda function as a target. So it's creating the target, right? So it's creating it, it's enabled. Let's see what's going to happen. Maybe it's faster than we thought, but I need to go back to my SQS and check the queues. Messages in the flight. So that means that message is being processed by the Lambda function. I can tell. What do you think is going to happen? Let's give it some time. It's still there. It's now 0. So that means that message was actually processed. So what do you think is going to happen? If we go to instances, it was running as when we left it. But if we check, it probably would have changed to stopped. Yeah, it's no longer in a running state, because that's exactly what that Lambda function was built for. When there is an alarm, run a Lambda function and stop the machine, right? This is just a very good sample of showing you from alarm to an SNS to an SQS and to a Lambda function, right? But it could be anything. So just so we start all over again and show exactly how it works, we'll go here and then we'll start the state, like we'll start the machine again. So in this case, we are going to start it so that we can actually see it work, right? Because we created it and there was already one message that was there, and then that was consumed immediately, but we need to actually show it work now in real time. So we have it like this, we'll refresh it, it's running, right? So what we just need to go do is that we'll go back to Cloud Shell, right? And clear our screen, and then we run that same command that we ran before, right? So create the alarm again, and then we're just going to, so let me stay here and check the instance is here. Maybe we should even wait, let it finish initializing, right? So that we can be sure that it was stopped from our trigger. So let's just give it time, right? It's still initializing. I'm not sure how long it's going to take, but it shouldn't take long. So let's do a recap. We created SNS to show like it's a pub and sub, and we saw that SQS is one thing that can subscribe to SNS, right? And then we also saw that a Lambda function is an example we're using here, but there are many things that can read from a queue. The most important thing, you just need to read the message, process it, right? And once you process it, delete it from the queue, right? In this case, we're using Lambda because Lambda is really serverless. So all these, in as much as I'm not using them, I'm not going to incur costs, right? Because it's only from usage. And sometimes if you check, you need to process like so many messages before it amounts to something. Which is good, right? Because if you're exploring, there's no point you having to manage one server that is running because you just want to run a particular service, right? So what we did is that we created an EC2 machine, and there was an alarm that was attached to it, and we said, when this alarm triggers, send message to this SNS, right? And in that SNS, there was a subscription in the form of a queue that gets the message. And we said there is a reason why you have queue there, right? For persistence. Sometimes you want to put it in the queue and do something about it, right? It might be immediate, it might also not be immediately. It may be something you want to do later, right? And then in this case, I wrote a Lambda function that is triggered, right, for when there is message in the queue. And that Lambda right now got that message, process it, right? And there's just one action that Lambda function is doing right now. In this case, we're testing just one action, and it's just stop the machine that we created, right? Or stop the machine that triggered the alarm. That's just an example. It can be any kind of example you can think of, right? Remember, the cloud, you see all these services, but at the end of the day, it's really about how you want to use it, right? Depending on your use case. So we have this machine, it's still initializing. At this point, I'm not even going to worry about whether it's initialized or not, because it's not really what I want to show. But I have this alarm that is going to be triggered here. So I'm just going to trigger it, right? I don't even need to check any of the other parts. The only thing I need to keep an eye on is to check this machine. So I'm just going to keep refreshing. You can imagine the power, right, of being having services that are very distributed, right, and very more or less like they are not there's this separation of concern, right? I went to one place, I triggered an alarm, and immediately I came back to EC2 instance, and the machine is already stopping. So it means immediately it was able to trigger the alarm, immediately SNS got the notification, immediately SQS got the message, immediately a Lambda function has been triggered, and immediately the machine has been stopped. Just I think just in the blink of an eye, right? And that tells you the power of the cloud. That tells you why a lot of people are there, the innovations that people see, and what they're seeing, right? So, or what the how people innovate in the cloud very, very fast. So if you check also, if you go to log groups, just so you know that Lambda function is actually doing stuff, we can check. I think this is Lambda Pro. I don't know which of the function we are using, which of the log groups is. Let me see I want to see which of the log groups is using. So this is the Lambda function. Let me see monitor. So under monitor, I'm just going to do, let me see if I will see any logs that is being written. I can't really find any logs. Viewing CloudWatch logs. Let's see. There should be a log at least. Okay, so it's my Lambda function that is there. So let's see the events that were triggered. You can see this one was the last one that was triggered. Yeah, you can see it got this event. This is the event structure that I got from SQS, right? Like I told you, if you were testing, if a developer was testing, this is the kind of event they will use to test their function to make sure it's good. When it gets that, it was able to find the instance, it's running, it was able to stop it, and then it called stops instance is called for blah blah blah, like the instance ID, right? And then that was it. It did succeed, right? So we've shown end to end one of the ways you can use SQS, SNS, EC2 in the form of an alarm, right? And there are many ways. This is me using events in AWS, but it could be event from your application, right? That does something, triggers an SNS, and from the SNS, a queue is getting that event and then doing something else, right? So let's go back to our slide. I think there's just a few more things we need to see before we leave. So we talked about fan out. Amazon MQ. It's so if you think about it, if we just looked at SQS, right? But SQS is native to AWS. But there are people who probably when they were on premise, they had their own broker that they were using, and on moving to AWS, maybe they want to keep their broker for compatibility sake, right? They have many reasons you might want to keep your own broker service if you didn't want to use SQS. It means that if you already have, there is also a managed MQ, right? There's like Amazon MQ that you can use. It supports Apache ActiveMQ and then RabbitMQ, right? These are all different kinds of brokers that are different from SQS, right? SQS ground up AWS service that helps you, have your own broker in the cloud. But if you have one that you're bringing, you can also use any of these, whether it's the MQ for Apache MQ, ActiveMQ, or RabbitMQ, right? Lift and shift is one of the reasons you want to go this route. If you have like a lift and shift, you want to move to the cloud, you're thinking about moving to SQS, but in the meantime, you still want to keep your queue. Amazon MQ is something you can consider. It also has AMQP, many of these protocols that you support. Like if you have like Amazon MQ, you support it there. VPC deployment, if you saw SQS, we didn't put it behind the VPC, right? But Amazon MQ is going to be a cluster that you're going to be managing, and then you have to provision it, throw it inside of a VPC, and then have your security groups, do multi-AZ deployments, have your security groups control who can gain access to it and all that, right? So it's just like a cluster you have to also manage, right? I mean, AWS does the management for you, but what I'm saying is that you have to deploy a cluster, like an Amazon MQ cluster, right? As opposed to SQS that is completely serverless, nothing to manage, right? So obviously there's minor version, there will be upgrades that you'll be doing every now and then to upgrade the cluster and make it, upgrade to a bigger version. So when you think about it, MQ versus SQS and SNS, there's so many differences that is there. MQ is basically, you obviously need industry standards, right? Especially around the protocols that we've mentioned, and you don't want to use SQS, that's when you should use MQ. Also, people use it a lot during the migration phase, right? Remember, a lot of people move to the cloud, they are in on-premise, and they're still considering their move. So you use that, especially during your migration. Then, after migration, you can now start thinking of, so you do lift and shift first, and then after that time, you start thinking of, okay, I now want to more or less like do a shift to SQS, right? Use SQS and SNS when you're building cloud native. That's exactly what we show. All cloud, right? Cloud native. There are companies who start cloud native. So if you're working for a cloud native organization, you will use all the patterns that I've showed you. But some companies also will start with Amazon MQ, migrate that to the cloud, and then from there they can now start exploring SQS, right? So need unlimited scalability, like we've seen, it scales very, very fast for us. And customer optimization is also there, right? You only pay for usage, not keeping the cluster running, right? So what's the migration part? You can obviously move to Amazon MQ, and then from there, move SQS SNS. This is I'm saying is real world application. That's exactly how most people do it. It's that people start cloud native SQS SNS pattern, or you move your brokers to the cloud, and then from there, you begin to break it down, okay? When to use which service? I mean, SNS is obviously for broadcasting, right? So pops up. MQ legacy, if you have like legacy apps. So, but if you were building straight from the cloud today and you didn't want to use MQ, you can use SQS directly, right? So SQS decoupling, like if you wanted to decouple your application, So your decision factors will obviously be your throughput requirements, your message persistence needs, like how long you want to keep message. Remember, SQS will keep message for you for 14 days, but Amazon MQ obviously is a cluster, right? So you can leave your messages there for however you want to. The most important thing is that make sure you don't keep it up to a point where it's hampering the performance of your cluster, right? Protocol compatibility also is one of the reasons you want to go with, if you have like strong requirement to use Amazon MQ. And then cost consideration. Sometimes it depends on the model you choose. One could be cheaper than the other, right? So you have to do that benchmarking to see which one is going to give you the best cost if you move. Real world scenario is just here. Basically, everything we've talked about is a bit serverless. They're all serverless, not even a bit serverless. They're all serverless, but you can take it further. What it means is that someone can call an API gateway, which is also serverless, right? That pushes message into a queue, right? And maybe there's a service behind the scene that's going to process it. So API gateway can actually publish a queue to SNS. SNS can have queues behind it, and then the Lambda function can actually consume those events, right? And then consume those events from the queue. What it means is that, yeah, it's all serverless, right? Cool. Yeah, there's really nothing much. I think API gateway, we know what API gateway is. If there's like a service behind the scene, and you can even have like direct integration to call AWS services from API gateway. Okay. And then best practice security is enable encryption is one thing you need to keep an eye on. IAM policies, you've seen even a queue has like a resource policy that you can decide who can publish or who can read from the queue. VPC endpoints, if you go the Amazon MQ route, you need to create VPC endpoint to do your things. When you talk about cost optimization, that's when you need to think about long polling, right? So poll for long so that you're not just checking even when there's no messages, right? And then you can use appropriate message retention. Obviously, I didn't talk about kinesis, but kinesis is something I think we've talked about kinesis at some point, but you can obviously, kinesis is also another route you can take, but we've already mentioned it in a different slide completely. So what about performance batching? Right now we saw it was handling just one message from the queue, but in an ideal world, you fetch a batch, process a batch, and then move on, right? Back off, if something is failing, maybe you want to back off and retry after a while. You have to monitor the queue. That's where we didn't really go up to, but once you created the queue, there's like metrics that are already being gathered for you. How long your message is staying in the queue, what's like your queue depth. You have to see all those are metrics that you need to keep an eye on, like to know if your queue is being processed on time. And then dead letter queues obviously can help you for reliability. Multiple AZs, obviously, if you have your own cluster that you're managing in Amazon MQ, you have to deploy a highly available solution. And then if you have need for ordering, right, whether you're using a FIFO or a non-FIFO queue in this case. So it's been a very long, I won't say long, but at least we've gone through a couple of things, right? So we've seen synchronous versus async communication patterns, and we've seen how we can actually decouple the applications, right? Using this kind of pattern. Because we see all the elements that we looked at, they were all decoupled, right? They knew exactly when to come in, right? So for example, if there was no message in the queue, Lambda is not going to do anything. There's no message in SNS, the queue is not going to fetch anything, right? So there was this decoupling between the services, and it can also work with your microservice architecture if you have. So SQS Standard, FIFO queues, depending on which route you want to take. SNS will obviously do the pop and sub for you. Final patterns, you can combine SQS and use filtering attributes on subscriptions from SQS to actually do a final pattern in a very serverless and high throughput manner, right? And then Amazon MQ you can obviously use for traditional messaging protocol support if you wanted to go that route, or you were doing like a migration and you wanted to start with Amazon MQ before you start exploring SQS, right? And then obviously you can look at the decision metrics to know which one which one will fit your use case, right? Cool. That was I don't know, very short, but I think I've been able to show you some of the things that these services have and how you can use it with that small demo. And I hope that you've gotten some value from seeing how those services work in AWS. That brings us to the end of this class.